All right. So good evening, everyone. Cool. Um, so I guess we're good to go. And first of all, welcome to the another live stream of the Excedient DSA community. In this session, we will be solving some of the very famous interview questions that have been appearing in coding interviews, and we'll try to understand the approaches, and most importantly, try to understand the efficient approaches. And we'll not be discussing the solutions in this session, but rather understand the concept behind the problem statements that we have. And I'll be using lead code for this session. You can already find the four problems that I have already solved, and we'll be discussing these four problems today, which includes remove duplicates from a given sorted array, best time to buy and sell a stock part 2. The part 1 has already been explained in the previous sessions as well. We'll also see how to rotate an array with a given number, default number that is given to you, and we'll be rotating an array. And we'll also find out how to calculate, or how to just have a solution for duplicacy in our array, given array, right? So there are four different questions that we'll discuss in this session, and so let's begin, right? The first question, which is remove duplicates from a sorted array. Let's understand the question first of all. Here we have an array of name nums, which is in non-decreasing order. Again, it is a sorted array, guys. So this is very important for us, which is already mentioned for us. That is, the array is already in sorted, but it is in non-decreasing order. Now, what we have to do is we have to remove the duplicates from in place such that unique element appears only once, and the relative order of the element should be kept the same, right? Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements, right? So let's understand this in much more layman language, right? Basically, we have a given array, right? And we have a given number, let's say k, which is, let's say, 2 3 4, whatever. We need to figure out if that number has been appearing multiple times in the array, and if that is appearing in the multiple times in the array, then we have to just print that particular value itself, right? So let's see some test cases here. First array, we have 1 1 2. Here our first index, we have 1, and now we will check if we have 1 again appearing in any cases, right? So yes, we do have ones again in the second place itself, and thus there is a duplicate element present in this array. Thus we will return back that yes, we have the return, we have duplicates value in the array. Thus we will remove that duplicate value and print what is the length of that array without the duplicate value. So if I remove 1 from here, like if I just have to print unique values here, we will only have 1 and 2, right? And if I have to calculate the length after that, we will have the length as 2. So our k value becomes 2 here, and we'll return the value as 2 as answer, right? Similarly, in the next case, if we see, we have two zeros, we have 3 1, we have again 2 times 2 appearing, and 2 times 3 appearing, and then we have 4. So overall, if I have to again find the unique values here, I'll have 0 1 2 3 and 4, right? So our k value in this case becomes 5. That is, we have 5 as a length of this array, the length of the unique array. The first brute force approach that comes to my mind as soon as I see this question is, I can just iterate through my array first of all, right, and find out if there are any duplicate values, and I'll be popping those duplicate values out. That's my brute force approach. Why? Because it will definitely take a lot of time to iterate over the array again and again, and figure out how many times there is a duplicate array, and we'll try to pop the duplicate values every time we encounter them, right? But that is not an efficient approach, and that is definitely not what the interviewer is expecting you to give them. What we can rather do is find out a more efficient approach where we do not really have to iterate again and again, and we can find out the values in a single go, right? If we have duplicate values in the array, we can find out that in a single go. So in this case, what we can do is, let's say if I just the array is already sorted, right? So let's assume that I take a value count, right, a variable count, where which will be like just a hash map. We can just store the value of our index, like let's say 1. I'll be storing the number of times 1 is appearing in that value of count, right? Let's assume that. In that case, what happens, let's say I have 1, now I move to the next value, I have another 1, I increase that count value, right? I'll not be storing 1 in another location. So one, now in this case we have 1, and the next one I'll just increment the value of count, and then when we have 2, I'll just add this 2 to the previous position, right? So again, let's understand this once again. We have 3 positions available here, 0 1 and 2 indexes, right? And what I'll do is, I'll go to the first position, I'll have 1 here, and then move to the second position, again have 1. So I'll not, assign any value here, but rather I'll increase the value of count for 1. And then I move again to 2. And in this case, find out that, 1 and 2 are not same, or they're not equal. Thus, I'll assign 2 to the previous position, right? In this case, what happens, my unique, I find out what is the unique array for myself, right? I have a array where I have 1 and 2 right now, and then I can also calculate the length of that array, right? So if I have to just, let's another take another example. In this case, I have 0 0 1 1 1 2 2 3 3 and 4, right? Thus if I just have to again do the same approach, I go to the first position right now, and let's assume that I have a count variable for 0. Now the count variable for 0 this time has 0, right? Because it does not appear even once. Now as soon as I move to the first index, the count value becomes 1. As soon as I move to the next second value, the count value becomes 2, right? But definitely I have not changed, or I have not allocated this position to any other value, right? Or any other particular 1 2 or 3 or 4, right? As soon as I move to 1, this now I find out that 1 is greater than 0, and definitely 0 and 1 are not equal, so I assign 1 to this particular position, right? So now in this array I have 0 1, and then the count of 0 is 2 and count of 1 is 1. After three back-to-back iterations, I find out that, the count of 0 is 2, count of 1 becomes 3, and then I move to the next element, that is 2. In this case, 2 is not equal to 1, and definitely 2 is greater than 1, right? So I again assign 2 to the previous location. In this case, it will be this, right? So in this array right now I have 0 1 and 2, and we have count variable for each, where 0 is 2, count for 1 is a count value for 1 is 2, 3, and count value for 2 becomes now 2 itself, right? Similarly, count value for 3 becomes 2, and count value for 4 becomes 1. What we will ultimately compare is the length of the unique array that we have, right? So we do not really have to think about or give our focus in the number of number of times a particular value is repeating in the array necessarily. But what we will focus is, after I increment my count value, and I assign my values to the previous positions based on the approach or the algorithm that we have decided, what is the size of my array after that particular step, right? So we just have to calculate the size and then just print that size, right? So that's a very basic approach that we can take, right? If I just move to the code again, I definitely want you guys to code it yourself, right? Because the concept is pretty simple, and it is a very easy problem if I have to talk about, but yeah, a bit tricky, because you have to understand the logic behind it, and if you can crack the logic, it becomes very easy to solve, right? So again, you can solve it in any language of your choice, but I'll definitely want you to do it yourself. But let's just go through the. I'll definitely run you through the code as well, so that you can have an idea about how to code it. Okay, another important point, they've definitely given us some constraints here, where we have already, the length of the array should be less than 0, and less than equal to 0, or it should lie between 3 to the power 10 to the power 4. Again, you can calculate it, and you can find out that, because of whatever algorithm you decide, if you are using our algorithm, then definitely it is under the constraint, and we are already satisfying the constraint. But if you are using an algorithm of our own, do make sure that you just calculate it and check if the constraints are met. If it doesn't met, then you can find out that a condition of t area or something like that. So this is the array that I have, right, and the solution that I have for this question. Again, there are always base cases for each problem, right? So again, this question also has a base case, right? We'll definitely check if the array size is 0. So let's say the input array that I receive has 0, right? There is no value, or there is an empty array, right? In that case, I'll have to return 0. That's a base case. After that, I take an index, a value named ind, which represents the index value, right? And what I do is I run a loop, right? Now, if you observe it carefully, the best part about this entire algorithm is that I run that loop for only a single time, right? I do not have to run that loop again and again, right? And there's only single loop of for, which I run from I minus 1, I equals to 1 to num of size. So we calculate it to size and I plus plus, right? After that, we calculate if nums of I is equal to nums of I minus 1, right? So basically, because again, this y num I minus 1, if I again run you through the first line of the code, it says non-decreasing order, right? Because of this non-decreasing order, I realized that I have to compare my values. I could have compared with I plus 1 here, but because of the term of non-decreasing order, I'll have to compare with I minus 1 in this case, right? So what I do is I'll compare nums of I with if it is equal to nums of I minus 1. So basically, I compare it to the previous location, right? So if you understand the logic behind it. And if it is equal, then I continue, right? And if it is not equal, then I assign it. And first of all, we check, right, if nums of I and nums of I minus 1 is equal or not. If it is equal, then we continue it. Like we just hypothetically assume that we have a count value and variable, and we have assigned that number of occurrence to that count variable, and we continue it, right? If it is not equal, then what we do is we assign that unequal value or the greater value, basically because it's a non-decreasing order array, then obviously we will have a value which is greater than the previous element, and we assign that greater value to the previous location, right? Now, in this case, what happened at the end of the day, what we will observe, what we will have is we'll just have to run a erase function from beginning of the array to the end of the array, right? And just run that. What will happen is all the duplicate values that we have are now gone, and the array that we have has only the certain values which are unique, right? After that, what we will do is we'll return the size of that unique array. That is, we just do not return nums of size. That nums of size will return the value of the unique array, the size of the unique array, right? In this case, for the first case, if I just again move to the test cases, in the first case that we had, we'll have the value as 2. In the second case, it will become 5. So again, just summarizing the entire problem, you have an array, not sorted array basically, right? All you have to do is calculate the number of times a particular value is occurring, store it somewhere, and make sure that you assign the unequal values to the previous locations so that they become a unique set of value occurrence, right? The unique values, they come after each other, right, in adjacent values. And then just calculate the size of that array and return that size, right? That's a question and that's answer, right? Again, you can have a different approach as well, and you can try it of your own as well, right? So this is the first question. It's pretty simple. We'll move to the second one now. The second question again is a continuation of a previous problem. Again, if you have already solved best time to buy and sell stock, pretty famous problem, right? In the previous problem, that with the basic problem of best time to buy a sell best time to buy and sell a stock, we had we had a question where we had to buy a particular stock at a given duration of time and again sell it at a given duration to calculate the maximum profit, right? That was a basic question, and what we did in that question was we used to have a value for maximum profit. You have to have a value for the minimum value, and we'll used to compare the values, and we'll update our minimum value every time we'll have lesser value, right? That was a basic logic behind the earlier problem. But in this question, it's pretty different. So what it says, it's pretty similar as the earlier problem, but in this case, they allow us to have that transaction multiple times, right? So you will not buy and sell the stock for one time, but rather what you will do is you'll buy the stock and you'll sell the stock. Again, you can buy the stock and again sell the stock, right? So that is what the question says. After doing iterative, buying and selling of stocks, how in what way can, or what is the maximum profit that you can generate, right? So that is the entire question. Again, they have given us a constraint here, so you cannot have a condition where you will buy multiple times, one after the other, and you will sell multiple times. So it's not possible. It's illogical according to the question, right? So basically, what it says is, if I have a stock, let's say the first test case here, we have our array as prices, right? In the prices, yeah, in the prices we have 7, 1, 5, 3, 6, and 4, right? Now let's say I have bought a stock at 7, I can sell at 1, I can buy a stock at 5, I can sell at 3, I can buy a stock at 6, and I can sell at 4, right? I cannot do something like bought a stock at 7, I'll again buy a stock at 1, I'll again buy a stock at 5, and then I'll again sell it at 3. It is not possible, right? So you'll have to have, in order to buy a stock, you'll have to make sure that you have already sold the previous stock that you have bought, right? So you cannot have buy one after the other, or sell after one after the other. That's a basic constant that they've given us. Now, if I just check the first condition here, and we see that we have an array where we have 7, 1, 5, 3, 6, 4, and now our output becomes 7. So basically, on day 2, that is on price 1, right? This is a lesser value. This is a minimum value, right? And if I move to the next one, it is 5. So let's say I have bought a stock of value 1, and then I sell it on day 3, where the price value becomes 5, right? So again, 5 minus 1, the profit becomes 4, right? Again, 3 is the next value. Again, 5 and 3. If I can check for 5 and 3, obviously 5, if I buy a stock at 5 and sell it at 3, it becomes a loss for me, right? So I'll definitely not try to do that. Again, if I buy a stock at 3 and if I sell at 6, I have a profit margin of 3. right? So again, this becomes a pointer for me that I have a profit of 3 here as well, right? Again, if I buy a stock at 6 and I sell at 4, I get a loss, right? So I'll not consider this situation. So if I have to again run you through this, if I buy a stock at 7 and sell at 1, again, this doesn't make sense because I will have a loss of 6, right? But if I buy a stock at 1 and sell at 5, I end up having a profit of 5 minus 1, that is 4. If I buy a stock at 5 and sell at 3, I have a loss of 2, which I'll not consider. Again, if I buy a stock of 3 and sell at 6, I have a profit of 3. And again, if I buy a stock at 6 and sell at 4, I have a loss of 2, right? So we will ignore or we will not consider the situations where we have, loss, right? And we'll consider only the situations where we have profits, right? So in this case, initially we have this 1 and 5 makes a pair where we have a profit, and 3 and 6 makes a pair where we have profit. Now you can tell me that we can buy a stock at 1 and we sell at 7. This is not possible, right? They've already mentioned. We have to go from left to right first of all, and we'll have to make sure that if I buy at this index, then I have to sell at the next index, right? So if I buy at index 1, then I'll have to sell at index 1 plus I plus 1. Sorry, if I buy at index I, then I'll have to sell at index I plus 1, right? That's the basic logic. So I have two profitable situations here, 1 5 and 3 6, and I'll consider those situations, right? And then make the sum of the profit that I make, right? So in the first situation I make a profit of 4, and the second situation I make a profit of 3. And if I create a sum of it, I get the answer as 7, right? So that's basic explanation of the test case 1. If I move to the test case 2 here, I have another array where we have 1 2 3 4 5. Again, it's a sorted array, right? So if I just because it is a sorted array, now you can understand that we will definitely have like basically we will definitely have a single situation. Every situation we will have a profit, right? So profit remains constant here. So if I just take the output here, the output becomes 4. So let's say I buy a stock at 1, and if I sell at 2, I have a profit of 1, right? Now if I buy a stock at 1 and sell at 3, I have a profit of 2. Similarly, if I buy a stock at 1 and sell at not five, day 5, where the value is 5, I have a profit of 4. So obviously there is only single condition where here there is no multiple condition, because we do not have array where we have bigger values or lesser values in middle. It's a sorted array. Thus I can just easily consider that the best case that I have is the last element and the first element, and if I decrement them, I'll get the difference, which is the largest, right? So if I decrement 5 and 1, then I'll find 4, which is the largest value that of the subtraction that we can find out from this entire array. So that becomes our profitable situation, and according to the quotient, that becomes our maximum profit. If I see this situation here, I have 7 6 4 3 1, right? So if I buy a stock at 7, I sell at 1, it's a great loss. Buy at 7 and sell at 3, loss. So if I buy at 7, obviously I'm going to have a loss, because all the values that I have are lesser than 7, right? So that is pretty easy to understand. If I so again, this is very important to understand. So we definitely come through a pattern, right? The pattern is very simple. We have to buy the stock at the day where our value is minimum. We have to sell the stock at the day where our value is maximum, right? That's the simple logic that we have, right? In this case, because the array starts from greater value, and there is no greater value after that, right? Because we all already 7 6 4 3 1, it comes down, right? We do not have a value which is greater than any of 7 6 4 3 1 here, right? If I have 7 here, I do not have 8 9 10 any of these cases. Or if I have 6 here, I do not have 7 8 9 10 anywhere here, right? So always we have to have a value which is greater than the value that I have for the stock, right? So that I don't find here, because I don't have that in this case. So I'll consider the situation to have an output of 0, because we do not find our maximum profit in this case, right? So I hope this approach is also clear. Now again, if I have to summarize this entire problem again, it's pretty simple. We will buy the stock at particular day, and I'll sell the stock at particular day. I can have multiple buys and multiple sells, right? But having that said, I cannot have a buy sell condition. At the same point of time, I cannot have a sort of if I have an array like this, where we have the greater values, and then all the values are lesser than the previous values, then obviously we will not make up, will not end up having any sort of profit, right? So again, we have certain constraints given here. That is again for the length. Our solution and our algorithm satisfies this. In case you are running your own algorithm, make sure you calculate it once and then figure it out if that is working for you or not. So if I just again run through the solution here, again definitely I'll ask you guys to do it yourself, right? Because once you understand the concept, maybe you can, start exploring the solution yourself in your preferable language. You can solve it in Java as well, in Python as well. But I'll be solving it in C++, and the solution is pretty simple. Let's understand it, right? So what we do is, first of all, we have a vector, right? And we pass our array, that is prices, right? Then we calculate the size of the prices, right? Obviously, we have to calculate the size of the prices because we'll be iterating over it. We take an iterator that is I equals to 0, and then we take a profit as 0, right? We can consider I to be the value where we will be storing our minimum value. Just give me a minute. Um, All right. So we can consider the I to be the value where we will store our minimum values, right? So every time we'll encounter a minimum value, we'll just store it at I, right? So again, we'll run the while loop where we'll check if I is less than n, that is I is less than size, right? And that is a sell SP. That's just we are selling that particular stock at that particular value. Let's say SP is a value where we will sell the stock, right? So I'll assign that. Okay, I have this particular value. Let's say one, and I have assigned it to SP right now, right? I'll be selling at one. Then I can consider J and I. So I'll compare J to be a value where I'll be checking. If I just again take the test case here, I have 7 1 5 3 5 6 4. Let's say that I'm in 7 right now. The first case I'll consider is 7 and 1, right? So if I check for 7 and 1, I'll decrement 1 minus 7 here, okay? Because I'm buying at 7 and I'm releasing at 1, right? So our profit will become 1 minus 7. In this case, 1 minus 7 will be negative. Thus, we have a loss, right? So we'll ignore these cases and we'll move to the next one. I'll take 7 and I'll move to 5. Now, 5 minus 7 is again a negative value. So again, I'll ignore that case, right? So in that case, in this particular array, for 7, if I buy a stock at 7, at each value, I'll end up having a loss. So 7 is not where our profit, maximum profit lies in, right? So again, if I move to the next value right now our iterator comes to index 2, and now the value of stock becomes 1. I buy the stock at 1 and I sell it at 5. Now again, understand this, I cannot buy the stock at 1 and sell at 7. This is not possible, right? So I'll have to go by the left to right approach, right? So I buy the stock at 1 and I sell at 5, right? So obviously we have a profit, and I decrement 5 minus 1. Again, it is not 1 minus 5 but rather 5 minus 1. So again, right to left approach. So I decrement 5 minus 1 and I have 4. That becomes our profitable number. I store it in my profit value here, right? And so I'll be storing it in the profit value here. And similarly, I'll calculate it for the next iteration as well. So if I buy at 5 and I sell at 3, it becomes 3 minus 5, right? It again becomes negative, so it becomes a case of a loss for me, so I'll not consider that. Similarly, if I buy the stock at 3 and I sell at 6, it becomes 6 minus 3, so our value becomes 3, and it has a profit. So again, we'll be at the end of the in end we'll just addition or summation of our both the profits that we have observed, right? And that's it. And then I'll return the profit. So I guess this is also understandable to all of you. We'll move to the next question with that. The rotate array. Again, rotate array is a very famous problem. I guess many of you have already done that problem, or you have already solved the problem sometime in your, if you have already into problem solving, then you have definitely solved this problem, right? It's a pretty easy problem. But having that said, it's an easy problem. There are multiple ways to do this, right? So we will try to have a more better approach, and there is a another approach that we can take, which is a sliding window approach, which again you can just run through the algorithm. But here I'll be explaining in a much easier way, so that everybody can understand, right? So let's say we have a array called nums, right? And the values that we have is 1 2 3 4 5 6 7, sorted array, right? And the value of k is 3. Now, because the value of k is 3, I have to rotate this array three by 3 steps, right? So by 3 steps, what I mean is our 5 6 7 will come forward, and 1 2 3 4 will go backward, right? So again, I can do this in 3 different steps. I already have the a solution basically mentioned over here. If you are using STL library of C++, you can easily do it in three simple steps. So basically, what I'll do is I'll first of all reverse this entire array, right? After I reverse this entire, I have six. So I will have 7 6 5 4 3 2 1, right? So if I just write it somewhere, let's say I have reversed the array. So I will have an array of 7 6 5 4 3 2 and 1, right? Now what I'll do is I'll find out what is my k value. So my k value is 3, right? So what I'll do is I will go here, I'll calculate in the three positions and I'll reverse it individually. So now I have 5, 6, 7, right? And then after this step, our array becomes 5, 6, 7, 4, 3, 2, 1, right? In the next step, what I'll do is I'll again reverse the rest of the array that I have, right? So here I had 5, 6, 7. Now when I reverse the rest of the element or the rest of the array, I have 1, 2, 3, and 4. And that's the answer that we actually require, right? 5, 6, 7, 1, 2, 3, 4. So we just have to have three reverse steps, right? I'll first of all reverse the entire array and then reverse till the kth position and then reverse what is after or what is, apart from the kth position, the rest of the array will just reverse it out, right? So it's pretty simple solution that you can take. If I just run you through the code right now, we will be using another approach. Okay, we'll not be using the reverse approach. I just explained the reverse approach for quick solution of this question. But here, what we will do is we'll use the sliding window approach. What is a sliding window approach? Let's understand that now. So let's say I have an array of 1, 2, 3, 4, 5, 6, 7, right? And my count of k is 3, right? So I have to rotate my array three positions, right? So what sliding windows approach states is I'll create multiple windows like this. Okay, say 1 and 2 is a window, right? Let's say 1, 2, 3 is a window, right? Let's say 1, 2, 3, 4 is a window, right? And this window will be depending upon the size of the k that we take, right? So let's say the first window that I get is 1 and 2. Basically, the block that I get is 1 and 2, right? And then I have 1, 2, 3. What I'll do is I will keep on reversing the values unless and until my default k value satisfies. So what I'll do is I have, in this case I have 1, 2, 3, 4, 5, 6, 7, right? So I'll keep on reversing the values, or I can I basically say swapping the values. Okay, let's say we will have unless and until we have 7 at the first place, right? And then we have 6 at the first place and then we have 5 at the first place. So we will keep on changing the size of the window based on the value of k unless and until that is satisfied, right? And when we keep on doing it, iterating over it again and again, we will end up having the value that we actually wanted, that is 5, 6, 7, and then 1, 2, 3, 4. So we will keep on swapping the values unless and until we find this particular let's combination. You can consider it to be like that. So if I just run you through the code once again, in this case also I take a vector, right? And I pass the k value. Initially I calculate the size of the array and then I check for the, if the values k modulo n is equal to 0, because we need to make sure that our k is lesser than the size of the array. Obviously, if our size of the array is 7 and if I say k is 10, that is not going to work for us, right? So we'll have to check that condition and then return if that is true. Then we take a first value, right? A first variable which is initialized with 0, and then we calculate the middle value n minus k modulo n, that will give us the middle value, and then we assign last as n, right? So then we take next is equal to middle. So I take another value, say next, which is assigned to middle. So right now I have first, which is positioning at index 0. Let's assume that, right? I have middle, which is positioned at index mid. I have last, which is positioned at index last, right? At the last index. And similarly, I have next, which is positioned at the value of middle. I'll check if first is not equal to next. I'll swap my first and next, right? So again, this is what I was talking about. So I'll just check if my first is not equal to next. I'll just swap the values. What happens here is I just take a midpoint here and consider that, can we assume that every time we take a midpoint, every value beyond the midpoint is going to be larger than the midpoint, and every value lesser the midpoint is going to be, every value that is lower than the middle index is going to be lesser, right? So if I say 1, 2, 3 is definitely going to be lesser than 4, and 5, 6, 7 is definitely going to be larger than 4, right? So we use that logic here. Every time we encounter a greater value, we swap the values, right? And we keep on doing it unless and until uh, our combination is achieved, right? And then we check if next is equal to last, right? So next, again, this is the case where we operate with next, that is our middle value, and our last values, right? So 4 is equal to 7. We check that situation. If that is correct, then we continue it, and if that is not correct, then we again check for if first is equal to middle, and then we assign middle to next. So what we basically do here is, again, let's understand in a layman language. We take a mid value, right? Let's say we take the mid value as 4 in this case, and then we definitely know that values lesser than 4 are going to be lower, and the values greater than 4 are going to be higher, right? And we just compare 1 and 4, and every time we find a greater value we just swap it, right? So by once we do that, we have 4 3 2 1 and we have 7 6 5, and then we just switch their positions, right? So when we switch their positions, we have 5 6 7 and 1 2 3 4, right? So basically that is what we do, and this is the sliding window approach. And this is a very famous approach and very famous problem as well. And in most of the interviews, you'll find the interviewer looking forward to have this approach, right? And it definitely helps a lot if you are aware about this algorithms. There are many algorithms just like this, but this is one of the very efficient algorithms in order to rotate an array. And mostly the interviewer is willing to find this algorithm from you, right? Many times they can also give the reversal of it. They can also ask you to tell or give you the output, and they'll tell you, what is the number of steps that you can achieve this. And if you are using sliding window approach, basically then your number of steps is higher, but definitely it's a more efficient one. Right? Let's move to the next question with that. So next question is contains duplicate. So again, this is a very simple question. We have a given integer array of nums, right? And we'll return true if any of the value appears at least twice in the array, and return false if every element is distinct. So let's say if we have a nums array which is 1 2 3 and 1, we will return true if we have a value, or if which is again occurring once again, right? In this case we have 1 2 3 1, so again we have 1 occurring twice, thus we will return true. In this case 1 2 3 4, we do not have any value occurring twice, so we will return false. Now this is a very important question in terms of solving it in an efficient way. This is a very simple problem if you think it to be in a layman way of language. All I'll do is I'll iterate over my loop, I'll run a for loop, I'll calculate if my a of I is appearing again, right? And if I find it again appearing again, I'll return true, right? But this is not a efficient solution. This is a brute force approach. We need to have sufficient solutions to this, right? So what I'll do here is that if I just again run through this, I'll first of all sort my array, right? So as soon as I sort my array, what happens? I will figure out that all the adjacent values are going to be, we will have adjacent values that are equal if we have duplicate values basically, and if our array is sorted, then adjacent values are going to be equal, right? So let's say if we sort this array right now, I'll have 1 1 2 3, right? So 1 1 becomes our adjacent values in the array, and they are equal, so they definitely tells me that okay, you have a duplicate value in an array, so you can return true, right? So that's a very simple approach, right? And I hope you guys have understood it. All we'll do is we'll sort the array, adjacent values, we'll check for adjacent values, we'll check if adjacent values are equal. If any of the adjacent values are equal, then definitely we understand that there is a duplicate condition, and we do not have to really return what are the duplicate elements in this question, but that also becomes a question, and you can add it to this question itself, that return the duplicate values. But in this question they are not asking us to do that. So all we'll have to do is sort our array, figure out if we have duplicate values in our adjacent, we have duplicate value, similar occurrence of the same value in our adjacent values of the array. In case we have that, then we have duplicate values and we'll return true. In case we don't have that, we'll return false, right? And if I just again run you through the code, I'll first of all sort my array, right? And I'll just run a loop, right? Very simple loop. A for loop, again I'll check for nums of I, which is equal to nums I plus 1. If that is equal, then we will return true. If that is not equal, then we'll return false, right? So this is a very simple approach, but a very logical approach, right? This is where your analytics will kick in, and you'll have the interviewer whenever whenever you'll sit for the interviews, and if they just give you a question in, and they hardly will give you 2 to 3 minutes to have this approach in your mind, right? So you have to give the solution to the interviewer in at least 3 minutes or 4 minutes, nothing more than that. That is also too much. I'm giving it too much. You should be have this, and you should have this kind of answers at least for topics like array in 1 minute or 2 minutes, right? You just have to explain them raw. These are few of the questions that we discussed today. We'll again discuss few of the questions in the next sessions as well. But I definitely want to discuss the concept more, not focusing on the code, because code will change, the syntax will change based on the language you choose. But the concept will remain the same, and these are the most efficient ways where you can solve these top four problems. There are around 20 different problems under the array section, which are very important in late code. You can go and solve those problems, and we'll also share the source code in the CDN community channel after this session. In the next session, we will also solve questions, and then we'll move to a topic of linked list. We'll understand the linked list from scratch. and we'll also understand double linked lists. I will understand circular, all the different concepts that we have in linked lists, right? And after that, we will also have a session on linked list questions, which are interview questions on linked list. Again, we'll solve some LeetCode questions on linked list itself. Now, having that said, definitely, if you enjoyed the session, if you like the solutions approach, if you understood the concept, definitely do share your feedback in the CDN community channel, and you can connect to me in the LinkedIn account itself. If you have any queries, we'll be able to chat that out, and we'll be able to solve your queries. And yeah, definitely share it to your friends and connections if they like the video. And yeah, thank you so much. We'll catch up again in the next session, which will be on linked list, and will definitely notify you through the mails in your CDN community. Um, you'll just definitely receive the notification mails, and you can register for that session itself. So thank you so much, guys, for joining us in this session. We'll again catch up in the next session. Hope you guys liked it. Thank you so much.